Alright, for this one, this is going to be a lab, so this is called the strange case of Mole Airlines Flight 1023. Make sure to read this. Okay, it says 6:02, you and your team of medical examiners are called at the scene of a small airplane crash in a remote location. The place shows evidence of a pre-crash explosion. 8 victims are found at the scene, but none are identifiable by witness, dental records, or DNA evidence. 1 victim was murdered prior to the plane crash. Okay, you need to figure that out. Who was killed before the plane crash? The flight manifest shows, right here, the flight manifest, the names and some of the information of the victims. You must also use the available tools and information to identify each victim. You must also solve the murder mystery. Next, the plane. A section of the plane has been blown apart, okay, by an explosion. It appears as if the explosion had happened before the crash, so this is a residue. So you will have to do what I will show you right now to determine what caused the plane crash. What caused the plane explosion. Okay, so we got to figure out what happened with the boom. Here's the flight manifest. Here are the possible compounds. Okay, so what you're going to determine is the empirical formula. Okay, now they're giving you over here the victims. Okay, the only thing is that they're giving you where they found whatever substance they found in them. Okay, and these are the trace markers, the percentages, right? The percent composition. Now remember, we can't do anything with percent composition, so therefore you need to first assume that there's 100%. So when you do, right, I'm going to show you how to do number 1, so you can determine what the substance is, and then first you would have to determine all the substances, and then based off the flight manifest, determine which are the victims, 1 through 8. Okay. So this victim in the blood was found that it had 67.31% of carbon. It had 6.98% of hydrogen, 21.10% of oxygen, and 4.62% of nitrogen. So what you're going to do is, again, like in the previous one that we did of empirical formulas, you have to assume that it is out of 100%, and therefore you have to assume 100 grams. What that happens is that now you're going to end up with 67.31 grams. So all you're going to do is switch the name. You're going to bring down the number, but you're going to change the percent sign to the gram sign. And of course it's of carbon, 6.98 grams of hydrogen, 21.10 grams of oxygen, and 4.62 grams of nitrogen. Okay? Next step is to find the number of moles. So that means you're going to have to divide by the molar mass of each of these substances. The molar mass of carbon is 12, so you'll have to divide by 12 grams. Molar mass of hydrogen is 1, so you'll have to divide by 1. I hope you don't need a calculator for this one. If you do, no worries. Molar mass of oxygen is 16. And the molar mass of nitrogen is 14. Now we do the mass to find the moles, so you use your calculator. The first part here is going to be 67.31 divided by 12, and I end up with 5.6091, we can put 7. 6.98 divided by 1, 6.98, and these are all moles of their respective substance, carbon, hydrogen. And then the next one is 21.1, divided by 16. This one is 1.31875. Now you're going to ask me why so many numbers, because later on it helps you get a better precise, or in the hopes of getting a closer whole number. And then we're going to divide that by 14. 462 divided by 14, we get 0.33. So you look through all these moles, right? and you're gonna find out which one is smallest. The smallest one is this one, so therefore you're gonna divide all of these by 0.33. Okay, and see what we get. So here we know for a fact that we're gonna get exactly 1. And all of these are gonna be approximations, right? Our best interest here is to find the whole number. That's what we're after, a whole number, because this is a ratio. And we're going to divide that by 0.33. So we're going to end up here with 16.9974885, which we're going to round it off to 17. 6.98 divided by 0.33. We get 21.15151515 repeating, right? So we're going to say, we'll use it as 21. We'll see what happens, right? But of course, we have to compare with the chemicals that are found in the substance. Now we're going to do this one. Here I get approximately, well, I get exactly approximately 3.996212121212, which we can round up to 4. All right, so what's my formula going to look like? So we have carbon here. That's going to be C17, H21, O4, and N1, right? So we're not going to write the ones, we're just going to write N. So now what we're going to do is we're going to look for the possible compounds. So does that match that formula? Nope. About the next one? Nope. That one? Nope. 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 Keep going. No, C40. No, we want C17. C21. No. Oh, they're possible winner. C17, H21, N, right? And O4. Very good. So what do we find? We found cocaine. All right. Narcotic drug. So what you're going to write is all that information. You're going to tell me, okay, so what's the name of the compound? I'm going to put cocaine. And then the formula, C17H21, O4N, or you can put NO4, whatever you want, okay? Now you go on to the next one and you do the same thing. Yeah, you do the same thing for this one. If it has a little hash, that means it doesn't have nitrogen. That means that that means you're gonna eliminate all the ones that don't have nitrogen, right? All right, so first do all of these, and then once you figure this out, you're gonna compare it to these, the flight manifest, to determine which ones are the victims. Okay? All right.